announcing a shift. Hello, everyone. Today I'm sharing a major update on how I interpret light and its measurements. After long debates and careful self-checks, I've switched my working frame to particle plus emission frame reference plus Galilean velocity addition plus one-way measurements first. This video explains the reasoning, the conclusion, and why this interpretation is simpler and more persuasive. Half 45 to 230, the issue. Start with definitions. Every scientific debate begins with definitions. Our key definition is speed. Open quote. Operational definition, v text obs equals initial distance, elapsed reference time t. Close quote. With this definition, if the observer and the source move relative to each other, arrival time changes, and therefore the observed speed changes. That is our starting point. Now 230-40, 4 axioms, sufficient and minimal. I found that 4 simple axioms organize the phenomena coherently. 1. Particle P1, at emission, a photon leaves the emitter's frame with speed v0. 2. Common reference time, P2. We do not redefine time per observer to salvage a preferred value. 3. Galilean addition, P3, with observer's line of sight velocity, u parallel, t equals frac L v0 minus u parallel, q quad v text obs equals v0 minus u parallel. 4. Linked to observables P4. The photon's frequency, f, is its intrinsic value. The observed wavelength is d frac v text obs f. From these, red-blue shift, Romer delays, Bradley aberration, and the insensitivity of round-trip methods follow straight from definition, prediction, observation. Hashtag 440 to 710, why this frame is simple. Straight line causality. Causality becomes linear. If the observer recedes u parallel 0, v text obs equals v0 by u parallel decreases redshift. If the observer approaches, u parallel left increases blue shift. Taking f as intrinsic gives lambda equals v for f, shift equals speed change. Bradley aberration with transverse speed. Tan alpha approx u perp, v0 is u parallel. Right arrow, alpha, approx v0, quad, u v0. Romer delay, for distance change, delta L, delta t, approx delta L, v0. No space-time deformation or special synchronization rules are needed, only definitions plus the particle emission start. Number 710 to 10, Michelson-Morley's null, why it's inevitable. Consider the Michelson-Morley interferometer. The key is the reflection re-emission local reset principle. Each segment is a local emission event, source beam splitter, mirror reflection, re-emission, beam splitter, detector. The entire device shares one inertial frame, so the effective speed per segment is the same v0. Thus, parallel and perpendicular arms both yield a round-trip time, 2L to v0. The time difference, delta t, is 0, so no fringe shift by structure, not by lack of precision. By contrast, one-way, single path, time of flight directly shows the linear modulation, t equals L vz.u parallel. Round-trip methods are intrinsically insensitive to first-order effects. Number 10 to 1240, where it conflicts with the mainstream. Mainstream accounts often try to keep simultaneously photon-particle acknowledgement, light speed invariance, the same C in all inertial frames, and observer-dependent synchronization, Einstein synchronization, Lorentz transformations. But keeping our operational speed definition, v equals L/t, and Galilean addition means v varies with u parallel, clashing with invariance. To avoid the clash, mainstream frameworks redefine time and simultaneity per observer so that each computes vc. That move abandons our axiom P2 at the level of definition. By Occam's razor, the particle emission frame is simpler. 12, 4, 40, 50. Likely objections. Short answers, Q1. What about interference fringes? Don't we need waves? A. Interference patterns can be described with field phases or reproduced by geometry, timing, and distribution in a particle model. In round-trip interferometers, the local reset at reflections and the structural cancellation of first-order delays make null expected. Wave only is not a necessary condition. Q2. Isn't the evidence insufficient? The issue is method sensitivity. Round-trip is blunt. One-way TOF is decisive. We need a measurement strategy shift, not necessarily exotic hardware. Q3. Why treat F as intrinsic? A. In this model, F encodes the photon's internal periodicity. Then lambda equal V F follows, and spectral shifts map directly to speed changes, a one-line interpretation. 1450-1650 conclusion. My stated position 1, Working frame adopted, particle plus emission frame plus common reference time plus Galilean addition plus one-way first. 2. Logical verdict. This frame and universal light speed invariance are mutually incompatible. Michelson-Morley's null is structurally inevitable in the device's own frame. 3. Empirical path. Final confirmation should come from one-way tee-off and related setups. Round-trip methods are unsuited for the core question. This frame aligns definition, prediction, observation without internal contradictions, explaining key phenomena without extra conventions. Najrik's 1650 and 1910 proposal, open tests and collaboration. Let's move to public tests. Experiment A, one-way tee-off with a moving receiver, same F laser, vary relative motion, measure T equal L, V0, U parallel. Targets, delta T, U parallel L. Experiment B, dual baseline timing, binocular layout, 2 receivers with different direction components to capture arrival time differences and pointing changes. Goal, verify alpha approx UV0. Analysis C, astronomical reanalysis, Romer plus aberration. Extract seasonal arrival time curves and aberration amplitude together to confirm the one-way sensitivity. These are procedure-driven, not budget-driven. They're replicable and yield clear verdicts. 1910 to 20 ending. An invitation to recap. Fix the speed definition, adopt the particle emission frame, use Galilean addition, and prioritize one-way measurements. Then Michelson-Morley's null and the other key observations fall into place simply. This simplicity and consistency motivated my shift. I invite you to participate. Designs, data, critiques are all welcome. Let's verify the simpler, more decisive path together. Thank you.